Good morning, all of you. In last video, we discussed about the we start to discuss about the law of gearing. Start to discuss about the law of gearing. So we consider two curved bodies. Consider two curved bodies which represent the tooth of the gears. Which represent the tooth of the gears. Those who are engaged. Those who are engaged. So these two curved bodies. These two curved bodies are represent first gear. This curved body represent the second gear. Those are the engaging with each other, and first curved body rotate with center O1 with angular velocity omega 1. Second curved body rotate with center O2 with angular velocity omega 2. Both angular velocities are different as both are the engaged with each other. These angular velocity directions are the different. So we consider these two curved bodies. Now these two curved bodies come in contact with here A1 and A2. So both curved bodies are joined at a intersecting point or common intersection point A, common intersection point A. But in actual practice, at intersection point on gear first curved body or first gear and intersection point on second gear are slightly different, and these are considered as a A1 on the first body, A2 on the second body. And these A1 and A2 are the coincident points, as this A1 and A2 are the single point as both of gears are engaged. But in actual practice, this may be different as a A1 and A2. So it represents as A1 A2. So in this is also it is a A1 A2. Now through this point of contact, we draw a normal. We draw a normal MN. We draw a normal MN through this point of contact, and also draw a common tangent. Also draw common tangent RQ through this point of contact. Common tangent RQ through this point of contact. Common normal MN through this point of contact. Now through this, now again we draw a perpendicular here O2M. Again draw perpendicular O2M to this common normal and O1M to this common normal from center O2 and from center O1. So O2M is a perpendicular to this common normal MN. O1N is a perpendicular to common normal MN. And these VA1 and VA2 are the linear velocity. These are the linear velocity, and these are the linear velocity of A1 and linear velocity of A2. VA1 and VA2, linear velocity of VA1 and VA2. And these are the perpendicular. These are the perpendicular. VA1 is a perpendicular to the O1A1. VA1 is perpendicular to O1A1. VA2 is perpendicular to O2A2. VA2 perpendicular to the O2A2. So with this diagram, we start to derive this law of gearing. We go through start to derive this law of gearing. So this we already discussed in previous video. This whatever this construction of this diagram, which I discussed in last video also. Now with this common normal, common tangent, these perpendiculars to this common normal VA1, VA2 are the linear velocity of the first curved body, first curved body, second curved body, like this. Now these are written here. Whatever we discussed here now written here. Now this point. Now if you consider this distance from this point to this point, from this point to this point, and if you consider two triangles, this is a small triangle and this is a larger triangle. This is a larger triangle and this is a small triangle. If you consider these two triangles, and to this two triangle, this length is common one. This length is common one from A2 to this point. From A2 to this point, this length is common. So for small triangle, we can write as a this length as a VA1 cos alpha. For small triangle, this length we can write as a VA1 cos alpha. For larger triangle, we can write as a VA2 cos beta. VA2 cos beta. So this length should be same. this length is common and it should be same, and we can write like this: Va1 cos alpha, Va2 cos beta. And now this angles alpha and beta are the corresponding angles of the Va1 and Va2 with the common normal. Alpha and beta are the corresponding angle of the Va1 and Va2 with the common normal. And now Va1 and cos alpha, Va2 cos beta we can write. And now for this Va1 we can write as a V is equal to R omega. V is nothing but the R omega. R omega. R in this case for first curved body, that R is a O1A1. Radius is the O1A1 and angular velocity is a omega 1. So this Va1 now changes as a omega 1 O1A1. Va2 changes as a omega 2 O2A2. Cos alpha remain as it is, cos beta remain as it is. Now after simplification of this we will get a sum. Now for this cos alpha and cos beta again we can write as a O1n O1A1 cos. We write for this cos alpha. For this cos alpha we can write as a O1 n. For this cos alpha we can write as a O1n divided by O1A1. O1n divided by O1A1. And for cos beta we can write as a O2m. For cos beta we can write as a O2m divided by O2A2. O2m divided by O2A2. These are written here. O1n divided by O1A1, O2m divided by O2A2 for cos alpha and cos beta. By considering this triangle and this triangle, we can write for cos alpha and cos beta, and that will be written here. O1n and O1A1, O2m divided by O2A2. Now this O1A1 and this O1n get cancelled. O2A2 get cancelled, and now it becomes a O1 omega 1 O1n, omega 1 O1n, omega 2 O2m. This will be written. Now this ratio, angular velocity ratio omega 1 by omega 2 now becomes as a O2m by O1n. Now for this again we can write for this O2m and O1n by considering similar triangle O1p and O2mp. O1p, O1np, O1np, this triangle. This P point is this point. O1np, this triangle, and O2mp, this triangle. These are the similar triangles. So this ratio of these two sides, O2m and O1n. Now we can write as a O2p by O1p. This ratio we can write as a O2p by O1p. So if you write this, replace this O2m by O1n by O2p by O1p, we will get this. We will get this equation. Omega 1 by omega 2 is equal to O2p by O1p. Now this is nothing but the gear ratio. Or angular velocity ratio omega 1 by omega 2 is equal to O2p by O1p. So this angular velocity ratio we write in terms of this length, O2p and O1p. Now discuss about this. So this constant angular velocity ratio of this gearing, the normal at the point of contact divide the line joining the center of rotation in the inverse ratio of the angular velocity. So this ratio of angular velocity divide the line joining the center of this two curved bodies. In the inverse proportion. So center line joining of these two curved bodies is O1 O2. This O1 O2 divided by this pitch point, or this O1 O2 intersect by common normal. O1 O2 intersect by this common normal at point of contact at this point P. And this point P divide this line, point P, divide this line joining the center of this two curved body in a two parts, O1P and O2P. O1P and O2P, and this angular velocity ratio, are divide the line joining the two center points in the inverse proportion. So omega 1 related to the O1P, omega 2 related to the O2P, and these are inversely proportional. Omega 1 is related to the O1P, omega 2 related to the O2P, but in this equation they comes as a inverse proportion. So we can say that angular velocity ratio at the common point, divide the line joining the two center points, and divide the line joining of the two curved body, center point of the two curved body in inverse proportion. That is written here. So constant angular velocity ratio of the gearing, the normal at point of contact, divide the line joining the center of rotation in inverse ratio of angular velocity. Divide the inverse ratio of the angular velocity. So this law of gearing states that common normal at the point of contact always pass through fixed point on the line joining the center of the rotation. So common normal at the point of contact always pass through fixed point. So we draw a common normal Mn through this point of contact. This common normal drawn at point of contact always pass through this pitch point. P. This is the law of gearing. This is called as the law of gearing. So common normal Mn drawn at this point of contact A1 A2 always pass through the pitch point. P. This is nothing but the law of gearing. So this is represented here. Here also. So this is nothing but a law of gearing. So again we can modify this O2P by O1P. We can write for O2P and O1P as a O2M and O1N. This O2P and O1P we can write as a O1N and O2M. O2P, O2M and O1P, O1M, right? And now instead of this O2P and O1P, we write here as a, in terms of O2M and O1N. This becomes as a omega 1 O1N, omega 2 O2M, and this omega O1N, O1N we can write as a PN. O1N we can write as a PN. So this O1N and O2M, for similar triangle, this and this, we can consider O1N and O2M. This ratio we can replace by this length. We can replace by ratio of this length. PN. So this will become like this. So here we discuss about that law of gearing. So this again modified as a, in terms of the pitch length. Gearing is important as soon as you discuss about the tooth gear. This law of gearing is important. We should know this law of gearing in the, for this tooth gear. Now we discuss about the velocity of sliding in the mating teeth of this gear wheel. Velocity of sliding in the mating teeth of this gear wheel. So here that point of contact are we consider as a A1, A2. Point of contact considered as a A1, A2 for two curved bodies first and second. Two curved bodies second. And their velocity, linear velocity will represent as a VA2, linear velocity represent as a VA1. And difference in between these two is nothing but the difference in between these two is nothing but the velocity of sliding. Difference in between the two is nothing but the velocity of sliding in the mating teeth. So difference in between the components of that particular velocity, component of that particular velocity is nothing but the velocity of sliding, and that will be considered like this. Component of velocity A1 along the common tangent. So we consider component along the common tangent. We consider this component along the common tangent, this RQ. Consider the component along common tangent RQ. So this RQ is parallel to this. So we consider the component along this line. So this line is represent the sine term. This line represent for these triangles, for the small triangle and for this larger triangle. These lines and these lines represent the sine term. VA1 sin alpha, VA2 sin beta. VA1 sin alpha, VA2 sin beta. So these are written here. Component along the common tangent is VA1 sin alpha, VA2 sin beta. And difference in between these two represent the velocity of sliding in the mating teeth. These are written here. So VA2 sin beta minus VA1 sin alpha is represent the velocity of sliding in the mating teeth of the gear wheel. So this VA2 again we can write as a R omega. Again R for this second body is a O2 A2. Angular velocity is a omega 2. So R for first body is a omega O1 A1 and angular velocity is omega 1. So R omega written here. Sin beta we can write as a A2m. Sin beta we can write as a so this we can write as a these terms we can write this sin beta we can write as a A2m divided by O2 A2, and sin alpha we can write as a A1n divided by O1 A1. Sin alpha is right here. Sin beta we can write here as a like this A2m divided by O2 A2, and sin alpha we write here as a A1m divided by O1 A1. A1n divided by O1 A1 like this. A1m divided by O1 A1, A2m divided by O2 A2. Now simplify this. O2 A2 get cancelled, O1 A1 get cancelled. So this become like this: omega 2 A2m minus omega 1 A1n. Now this take common. This A2m we can write in terms of this by considering this pitch point. A2m we can write in terms of the pitch point. So A2m we can write as a this A2m. We can write in terms of the pitch point by considering this pitch point A2p plus Pm. A2p plus Pm, and this we can write in terms of the pitch by considering this pitch point. By considering this pitch point, we can write like this: A2p plus Pm. Similarly, for this A1n, we can write as a Pn minus A1p. A1n we can write as a Pn minus A1p. A1n we can write as a Pn minus A1p. So this will be remaining A1n. This will remain as a A1n. And this will written here. So this will written here. Now simplify this. Now simplifying this, we can get A2p. Now A2p A2P and A1P, this length are same. A2P and A1P, these lengths are same. So A2P is equal to A1P. So A2P take common, and omega 2 and omega 1, omega 2 and omega 1 take in this bracket. So A2P is common, as A2P and A1P are the same. As the A2P and A1P are the same. And remaining terms are the A2PM, omega 2 PM. Remaining terms are the omega 2 PM and omega 1 PM. Omega 2 PM and omega 1 PM. Remaining terms. Now this omega 2 PM, omega 2 PM is equal to omega 1 PM. Omega 2 PM is equal to omega 1 PM. So these are considered from above equation. These are considered from above equation. Omega 2 PM is equal to omega 1 PM. Omega 2 PM is equal to omega 1 PM. This is considered from the above derivation. Now, so these get cancelled. These get cancelled, and this VA2 sin beta minus VA1 sin alpha is equal to this term is remaining. This term is remaining A2P into omega 1 plus omega 2. A2P into omega 1 plus omega 2. This term is remaining. So this is the velocity of sliding in mating teeth of the gear wheel. This is the velocity of sliding in mating teeth of the gear wheel, where A1, A2 are the coincident point. A1, A2 considered as a coincident point. So these are the derivations related to the lobe gearing and velocity of sliding in mating teeth of the gear wheel. These are the derivation for the lobe gearing and the velocity of sliding in mating teeth of the gear wheels. So that are discussed here. So this velocity of sliding is nothing but, if you look at this equation, the velocity of sliding is nothing but the product of this bracket, product of this summation of angular velocity. This is the product of sum of the angular velocity and the distance from point of contact to the point of intersection. Distance from summation of angular velocity and distance of point of contact to the point of the common point, or point of intersection of the common normal and line joining the center of rotation. So for correct gearing, this point of intersection is the pitch point. For correct gearing, this point of intersection is the pitch point. So this velocity of sliding is nothing but a product of summation of this angular velocity omega 1, omega 2 and the length, and this length which represent length from point of intersection, from point of contact to point of intersection, of common normal, and this line joining these two centers of the curved body. So this is nothing but the velocity of sliding. So in the next video we discuss about the form of teeth. So these two derivations are important one, as we discussed about the tooth gears. Especially this lobe gearing is a very important, as we discussed about tooth gear topic. So these two derivations are important one, as a lobe gearing and the velocity of sliding at the point of contact. So in next video we discuss about the forms of the teeth.